Okay, guys, we're going to be talking about polynomial graphs this week and what we call end behavior. Okay, end behavior is an idea that will help us graph these polynomial functions next week when we start graphing these things. Okay, so what is end behavior? To put it simply, this is not the direct definition, but to put it simply, it is when what does your graph do at the ends? And that's pretty much what it is. Okay, and when we talk about ends, I mean, what does your graph do on the left side? Okay, so on the left side, is it the graph going up or down? Okay, and the same thing, the other end, we have the right side. Is the graph going up or down? Okay, there's a little more specifics to that, but that's essentially what end behavior is. And to figure this out, we're going to use the actual polynomial equation. Okay, so the first thing we want to look for to find end behavior, obviously we're going to need a function, but we are going to look for the coefficient. Okay, so the coefficient, or what we call the leading coefficient, this guy controls the right side of our end behavior. Okay, so if we want to know what our right side is doing, this is what we're going to do, okay? So pay close attention. If your leading coefficient, so what the heck is leading coefficient? It is the number in front or multiplying of the highest powered variable. Okay, we call that the leading coefficient. I'll give you some examples here. Let's just get this stuff down. So the leading coefficient tells you if the right side is going up or going down. So how do we know? So there's two options. Option one, if the leading coefficient, we'll call it LC, leading coefficient is positive, okay, then your right side of your graph is going up. All right, so again, the leading coefficient is a positive number. The right side of the graph is going up. The other option is if your leading coefficient is a negative number, then your right side of the graph is going down. Okay? So that's what leading coefficient controls. It controls the right side, and this is the first thing we want to find out. All right? The second thing to deal with in end behavior is the degree. Okay, so the degree of the polynomial, all right, controls if the left and right side are the same or opposite. And I'll explain that in a little bit. But, so the degree, I want you to think of it as it controls the left side. Okay, but the degree left side is dependent on what happened to the right side, as you will see. Okay, So what is the degree first and foremost? The degree is your highest exponent. Okay? So in your equation or function, we're looking for the highest power. All right? So how does it work? So how does it control the left side? We have two options. Option one, if your degree is even, so it's an even number, the left side is the same as the right side. Okay? So for example, if we know the right side is going up and we have an even degree, then that means my right side is also going, or that's sorry, my left side is also going up. Okay? So when you have an even degree, the left and right side will match. Okay? So I like to say, I put the same, but left and right side they match. Oops, I can't spell match. Okay? They're either both going up or they're both going down. Okay? If it's odd, and this is kind of easy to remember because odd is, just think opposite. That means it is the opposite or different than the right side. Okay? So that means the left and right will be different. All right? So that's pretty much it. The hard part students find is writing the notation for that. Okay? And that's just going to come with practice, and I'll show you with some examples. But this is what we're doing. So to sum it up, M behavior of a polynomial is a simple question. What is your graph doing at the end? So on the left side, is it going up or down? On the right side, is it going up or down? Okay, that's basically what we need to answer. Okay, how do we answer it? We look at the function, the leading coefficient, the number in front of the highest powered variable. If it's positive, then my right side is going up. If it's negative, then my right side is going down. Okay, once we have established the right side, then we look to the degree. So the degree is the highest powered exponent in your function. So it determines our left side. And how does that work? If it's even, it matches whatever you have on the right side. Okay? If it's odd, then it does the opposite of the right side. Okay? So let's do a quick example of this. All right? And remember, we're talking about the graph. So let's do it this way. Let's just say I had a graph and we want to know the end behavior, or write down the end behavior. So we have the graphs are going to start looking like something like this. Okay, this is an example of a polynomial graph. So we want to know the end behavior here. Okay, so what we're trying to figure out is, what is this graph doing on the right side? Is it going on the right side of my graph? Is it going up or down? So as you can see, it's going down. Okay, so what does that mean? That means this graph has a leading coefficient. Since it's going down, my leading coefficient has to be negative. So we would know now that my leading coefficient is a negative number. We don't know that number, but it's negative. All right. Now, since we know the right side has to be negative because it's going down, if you look at my left side, it's also going down. So we can say my left side is matching. It's the same. So when it's the same, that means my power has to be even. So my highest power, or degree, that's what we call it, degree, has to be an even number. Okay, this is just one example of what we're talking about. We're talking about a graph, and from this graph we got two pieces of information. Our leading coefficient number is negative because my graph is going down on the right side, and it's even because my graph on the left side matches what the right side is doing. And again, this is the right side of the graph. Is it going up or down? We already answered that. And this is the left side of the graph. Is it going up or down? Okay, so that's how you do it, or that's the information we're looking for in a graph. Up or down on the left or the right, and it could tell us some information. All right, let's get into some problems. All right, guys, let's try number 4. Okay, so we're trying to find the end behavior. All right, to do that, we need the leading coefficient first. So let's look at the equation. The leading coefficient, since we only have one variable here, will either be here or here. Okay, and all we care about is it positive or negative. So if you look, the leading coefficient here is, there's a 1 there and there's a 1 there. They're both positive. Okay, so that means my leading coefficient is positive. What does that tell us about the graph? So that tells us that the right side of my graph will be going up. Okay, so now once we have that, we now want the degree. Okay, so if you look at your equation, the degree is 2. That's the only exponent in here. Okay, the highest power we're going to have is 2. And this is actually in factor form. So when it's in factor form, we got to add all the exponents. All right, but in this case, there's only 1. So it's a power of 2. So my degree is even. So that means the left side, since it's even, the left side does the same thing as the right side. Okay, as you could remember here. So leading coefficient is positive, so it goes up. Okay, the degree is even, so it does the same thing as the right side. So that means my left side has to go up. So if this was a graph, and I don't know what the graph looks like, to be honest with you, but that means the right side will finish up and the left side will finish up. I'm not sure what's going on. We'll talk about what's going on later next week in the middle part here, like how many humps we get, how many times it turns. Okay, but all we know is that the right is finishing going up and the left is finishing going up. And that's what we got from our equation. Okay, so how do I write the end behavior? Okay, so this is how we're going to set up the end behavior. Okay, it always starts with the letter X. So we're writing the end behavior here. Then we have an arrow. So this is always what we do. Okay, and now we want to know what the right side or left side. I always start with the right side. So we want to know what we're going to put in here is letting us know what the right side is doing. Okay? So if you look, my graph, we're talking about the x-axis. Okay? So when we go to the right, when we go in this direction, my graph is going in this. So we're not talking about up and down right now. We're talking about left and right. So my graph is going this way. Will it ever stop going to the right? Okay? And the answer for these is no. For now, we don't have anything stopping it. So that means over here we call this positive infinity. So my graph is going to the right, and he's going all the way to positive infinity. Okay? So that's how we talk about the right side, positive infinity. Now, we want to talk we now have let everybody know we're talking about the right side of my graph. That's how you talk about the right side. You say positive infinity. Now we want to tell everybody what is going on with the up and down on the right side. So this part, the thing we're going to put here, represents, is it going up or down? Okay? So we already know the right side, which is the positive infinity side, is going up. Okay? So my graph on the right is going up. Well, now, as we go up, we use the y-axis, or the f of x axis. Okay? That just gets them used to writing this out. So as we go up on this line, we're going up. My graph is going up to, it never stops, so that means it's going up to positive infinity. Okay, so my graph is how you translate it. On the x-axis, we're talking about the positive infinity side, which is the right side. And on that side, my graph is going up to positive infinity. Okay? So that's the right side. Now we're going to do the left side. X. And now we want to talk about the left side. So we want to put a number in here that represents the graph on the left. So we're on the x-axis again. That's why we're using the letter X here, to let everybody know we're using the x-axis to let you know where we're at. So on the left side, what's going over here on the left side on the x-axis? That's negative infinity. So we are talking about the negative infinity part of the graph, the left side of the graph. Okay? And on that left side, my function is doing what? Is it going up or down again? Okay? So we look. Remember this, if it's going down, it would go down here, which is the negative infinity direction. But my graph is also going up again, and it's going up towards, when it goes up, it's going towards positive infinity. Okay, and that is how we write end behavior. It's two statements. First, we got to let everybody know, are we talking about the right side or are we talking about the left side? Okay, and then we have to let everybody know on the right side, is it going up to positive infinity or is it going to go down to negative infinity? And we do the same for the left side. Okay guys, let's try number 5 and then we'll also do number 8. Okay, so number 5, we always start with leading coefficient. So my leading coefficient is -3. Okay, so we're looking for the highest powered variable and we look for the number that's multiplying with it. In this case, it's -3. So this is my leading coefficient. And we don't care about the number right now. All we care about is it positive or negative. So my leading coefficient is negative, and what does that mean? It means my right side is going down. Okay? So what does that look like on a graph? So on a graph, the right side of my graph, this is just a sketch, guys, is going down. Okay? Now, once we have the leading coefficient, we want the degree. And the degree is the highest powered. Okay, so since my equation's in standard form, okay, in number 8 we have it in factor form, which does a little bit different when we find the degree, and I'll show you what I mean by that. So when it's in standard form, we just look for the highest powered. In this case, it's x to the 5th, and that's the number we're looking for, the highest power. So 5 is my degree. Okay, and in degree, all we care about is it odd or even. Since it's odd, if you remember the rules we talked about over here, okay, so we have a leading coefficient that's negative. That means we're going down on the right side. Since it's odd, that means the left side does the opposite of the right side. Okay, so that means my left side does the opposite of the right side. So since the right side is going down, my left side is doing the opposite. It's going up. So what does that look like in a graph? My left side's going up. Okay, so now we know our end behavior. We just have to write it out. So like before, we always start, this is end behavior, x, arrow, okay? And we want to let everybody know what side are we talking about first. So we're going to put something here to let everybody know that we are talking about, I like to talk about the right side first. So the right side in our graph is this side, okay? So that means my graph, since there's an arrow, will always go this way. It's going to go this way and down at the same time. So it's going to be doing this. All right? So that means on the right side, we're talking about the positive infinity side, because this is the right side in the direction my graph is going in the right direction. So it's positive infinity. So that lets everybody know. We're now going to let you know what's happening on the right side. Okay, so now we're going to let everybody know what's happening. Is it going up or down on the right side? And this is the second part of end behavior. So we know my graph is going down. Okay, so we use not the x line. X line tells us left or right. Let me put that in to remind you. Okay, now when we talk about up and down, we use the function line or the y line. Okay, and since we are going down, that means we're going down this y line, and then we're going down, which means our graph is going all the way down to negative infinity on the y line or that function line. Okay, so that means we fill in here, and it's going down in this case to negative infinity. Okay, we just got done with the end behavior on the right side. Is going on the right, it's going down. That's how you state it using notation. Okay, now we have to do the left side. So the left side, so on the left, so let's look at my function. It's going on the left side, so using my x axis, my function does this. It goes up and to the left forever and ever. That means my function is going on the left side, it will go to negative infinity. Okay, that represents the left side. Now on the left side, now that we're talking about the left, what is my graph doing? What is my function doing? And this is, now we use the f of x line to measure that. Well, we know it's going up. So how far is it going up? Well, since there's an arrow, this thing's going to keep going up and up and up. Okay? Up, 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 up. And what is up, 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 up on the y line? Well, that's positive infinity. So we know it's going up, and it's going up towards positive infinity. Okay? That's how you do end behavior. So these two statements are end behavior for this function. Let's do 8 a little faster. Okay, leading coefficient. Let's find that first. All right, so this is in factor form, which is different than what this one was in. It's a standard form. Standard form is a lot easier to see. Factor form, not so much. So in factor form, we have the highest powered, look for him, and look for that parentheses. Okay? So we want to check, is he positive or negative here? So what's the leading coefficient? It's 1. But here's where it's different in standard form. You also have to look at the second parentheses. Okay? Because we actually would multiply these together, so they actually become 1. They turn into this, which becomes 1. So you're going to have to look at every single coefficient with the variable. So is this positive? Yes. Positive? Yes, positive. Since they're all positive, all the variables are positive, that means my leading coefficient is going to be positive. Think of it this way, we're going to multiply these. Okay? So a lot of times you would have to check that. Majority of time, guys, though, your leading coefficient is just going to be the guy in front, right here. Okay? I think that's how we're going to just make it simple. So if it's positive, our leading coefficient is positive. So just kind of look in the front, but just be careful. If one of these variables had a negative in factored form, then it might change this. But I doubt that's ever going to happen. All right? So my leading coefficient is positive. And what does that mean for the right side? That means my right side is going up. So let's sketch this really quick. Okay, we'll do a little small graph down here. So my right side's going up. Okay, now let's talk about the left side. So the left side is the degree. Okay, so the degree gets a little weird when you're in factor form. So what does the degree look like? Most people would say 7, but what you have to understand in factor form, since this guy's going to multiply with this guy has an exponent of 1. So altogether, we have to add these exponents in factor form. So we have 7 plus 1 more. That means my degree is even, not odd. Even because you would add the exponents. All right? So our degree is 7 plus 1 more, 8. So that means my left side matches my right side. Since it's even, they match. So that means my left side is also going up. So let's put that. Okay. So what does that look like when it comes to end behavior? So we're going to write that in here. So in end behavior, you start with x. Okay, and we want to know on the right side. So on the right side, my graph will go all the way to the right because it's going up and to the right. That's what this means. So looking at the x, the right side is represented by positive infinity. Okay, that's over here. Positive infinity, that's my x. That's the right side. Now that we know we're talking about the right side, we want to let everybody know, is it going up or down on the right side? So that's when we look at the y line or the function line. Is it going up the function line or is it going down the y line? Up the y line or down the y line? So it's going up the y line, and that's going up to positive infinity. Okay, so positive infinity on the y line is up here. And my graph, as you can see, is on the right side is going up. Now, we talked about the right side. We have to now talk about the left side. So the left side is this side, and on the x-axis, the left side is the negative infinity side. Okay, so that means we're going to be talking about the negative infinity side, the left side. What is my graph doing? What is my function doing? Is it going up or down? Since it's going up to positive infinity as well. Up to positive infinity on the y line. Okay, hopefully this helps. Just take some practice, all right? Let me get you the checking code and get you out of here.